So our last section is section 5.5, which is on the substitution rule, or sometimes it's called U substitution. Now this is a process that's used to make an easier problem to integrate, and you'll see it also in Calc 2. So most of the time we're going to let U equal what's in parentheses. Also, after the substitution step, there should be no x's left. And U substitution, this is the opposite of the chain rule from derivatives. So this kind of is the reverse of that. So if we look at number 1, if I were to try and integrate that, if I don't use this new process of U substitution, the only other way to do it would be to distribute that, so like FOIL it 4 times, which we don't want to do. So my process is I want to let U equal what's in parentheses. So that's going to be the 5x plus 3. And then the next step is you actually want to take the derivative. So it seems kind of counterintuitive, but we actually need to take the derivative. So the derivative of U is 1 du, or you can just put du. The derivative of 5x is 5 dx, and 3 goes away. So then my next step is I'm actually going to move the 5 over. So this will be 1/5 du is equal to dx. So I'm dividing both sides by 5. So this is the information that I'm using because I'm going to make a substitution here. So where there's the 5x plus 3, I'm going to substitute in u, and where there's the dx, I'm going to substitute in 1/5 du. So my new problem becomes the integral of u to the 4th times 1/5 du. And then you can actually integrate now. This is something that we know how to integrate. So the 1/5 I'm just going to write off to the side times u to the 4th. If I integrate that, that's u to the 5th over 5 plus c. And then if I start simplifying, now I do want to substitute back in. So my final answer, I don't want to have u's, I want to have x's. So I want to substitute back in what my u is. So this is 1 over 25, 5x plus 3 raised to the 5th, and plus c. So you want only x's. So we want all x's and no u's in the final answer.